The next lemma is to prove the following. We let X be a topological vector space again. Then every neighborhood of 0 contains a neighborhood of 0 that is balanced. So let's call our neighborhood of 0 U for reference. So this is U. And let's call the other neighborhood, the one we're supposed to find now, W. So we have to prove that inside U lies W, and W is balanced. Now remember that one of the axioms for a topological vector space was that the usual vector space operations, meaning addition of vectors and scalar multiplication by elements of the scalar field, are continuous, and we are going to use that scalar multiplication is continuous now to say that there is a neighborhood V of 0 such that alpha V is inside U, provided the absolute value of alpha is less than some delta, which we pick with respect to V, of course. Now we take the union over all sets alpha V, and we call this union W. And this is our balanced set. So let's check that it is indeed balanced. Remember to say that W is balanced means that A times W has to lie in W for every scalar A which has absolute value less than or equal to 1. So let's pick an arbitrary element of W. This has the form some alpha times some element of V, let's call it small v1. And if we multiply this by A, we get a new alpha. So let's call our first alpha alpha1 for reference. Then alpha2 is just A times alpha1. And note that the absolute value of alpha2 is the absolute value of A which is less than or equal to 1 by definition, and times the absolute value of alpha, which is less than delta. So the absolute value of alpha 2 is less than delta, and this proves that this element A times alpha 1 V1 is in W, because W was defined as the union over all these sets alpha times V, where the union was taken over the alphas. So this proves that indeed W is balanced, and this concludes the proof of this lemma.